First column. You can start.
Okay.
So we're going to start with the alkali metals. They live in the first column. So how many valence electrons does an element that lives in the first column have? 1. What kind of ionization energies do they have? Low or high? Very low. Okay, they love giving away electrons. They love it a lot. And so what we're going to do is see how they give away electrons with something very common, which is just water. Okay, so I've taken water, distilled water, and I'm putting in the beaker. And then the reaction says to take the directions say to take a small piece of lithium and react it. Now, the lithium metal itself, I'm just going to show you, it's really tiny. We don't use a lot of it. Can you see that it's floating in something? Yeah. Okay, can you guys all see that down there?
Keep it from reacting with air.
Exactly, it's to keep it from reacting with the air and the water. So it's kind of oily right now, but you can see I can kind of smush this piece of metal. It's really soft. It sticks really well to the tweezers. So watch what happens as I drop it in the water. Okay, and it takes a little second. I'm going to cover it with the wire gauze. But for those of you that are close, what can you see is happening? It's bubbling. So when we see bubbles, what do we assume that is a sign of?
Heat.
Not
energy.
Heat necessarily.
Energy.
A gas. A gas. I heard Dan say it, okay? So gas is being produced. So that tells us that it is a chemical reaction. That's one sign, right? Now that was pretty exciting, but maybe not as exciting as it could be. Okay? Now I'm not asking you to time this with actual numbers, but did this go fast?
Kind of
fast.
Seconds.
Yeah, not terribly slow. It's still reacting. Okay? And the next thing it asks you to do is to take something called phenolphthalein. Now, phenolphthalein is just an indicator, and it turns pink when there's a certain kind of ion present. It's called the hydroxide or OH minus ion. So watch what happens when I put it in. Okay? Did it turn pink? Bright pink, right? So there is definitely some kind of chemical reaction happening there, right? Okay, so I'm going to set this one aside, and now you guys can, I'll give you a second. If you need time to write your observations down and I'm going too fast, you just tell me. All right, are we good? What's the next metal it asks you to test? Sodium, right? That's a pretty big piece.
Do it.
You can throw that on my desk. We gotta leave some for Miss Kaufman, so I'm actually gonna cut this. Now watch, if you guys can see what I'm doing, this is really soft. This is the dullest knife. I probably wouldn't even cut my finger with it, and I can just slice right through that metal. Okay? All right. So now I'm going to take this piece of sodium. Now sodium is below lithium on the periodic table. So what is it as it compares to ionization energy? Would it be higher or lower?
Higher. Lower.
As we go down, they go down in value, right? So it wants to get rid of electrons even more. So what should you predict in terms of rate? Should it be faster or slower than the lithium?
Faster.
Faster. So let's watch the sodium now. I'm putting a cover on that one because that gas sometimes makes people cough a little bit.
The other one did.
The other one did? Yeah. What can you tell me about the violence, like the rate of bubbling and stuff? Does it seem faster than what the one before? Can you see it underneath there, Marco?
Yeah.
Yeah? Okay. It's bouncing off the glass. It's moving all around. So in terms of this reaction, would you say this is faster or slower than the lithium? Faster. We use the word kind of violent. I mean, it's not like punching anybody, but violent means that it's a little bit more vigorous. Okay, so I'm going to do the same thing with the phenolphthalein. Since they live in the same column, they're part of the same family, they should react similarly. So what do you think will happen when I put this in it? It should turn pink, right? So let's go. Did it? Okay, too bad it's not Valentine's Day. That would be a pretty color for that, wouldn't it? Okay, last one. What's the next element that we're going to be dealing with? In this one, it's potassium. This is the last one that I will tell you that I can legally have in a high school chemistry lab. It would be against the law for me to have anything below this in the periodic table. What does that tell you?
It's dangerous.
It's pretty dangerous.
dangerous.
Yeah, they get more dangerous. Okay.
Can I put one in my pocket?
That might hinder the rest of your life, just so you know. Okay.
And this kid.
And his kid. Or there never will be any. All right. So here we go. Potassium. Now this one you want to watch because it's going to go quickly. And I'm going to tell you that it produces some heat. So if you watch quickly and we do it right, you might actually see the heat ignite that gas on fire. You ready? Okay. Okay. Did you notice the color? Can you see the color of that flame?
Kind of like
It was a
yellowish.
little bit yellow, but did you see that there was a little bit of like a purpley pink color to it?
Yeah.
Okay. That is, remember when we did the potassium and the flame test? Same color.
Yeah.
Same thing. So that gas gets so hot that is being produced, those bubbles get so hot and it produces so much energy that ignites it on fire. Okay? So what do you predict if I do this?
Pink.
Pink.